In this lesson, we're going to get a little more complicated with quantified predicate logic and symbolizations. We're going to talk about what happens when you have when you need more than one quantifier and the scopes of those quantifiers overlap. We're going to go over this by working through some problems. These problems are all discussed in the lesson portion of the logic book starting on page 286. These ones and a bunch more. So we're going to work through each of these and make sure you understand how these work as we go. So first we have every animal likes every animal. Now we have just one two-place predicate for likes, right? We have LXY for X likes Y. And here we've got two claims that need to be quantified. Every animal likes every animal. Here we've got two universal quantifiers. So our paraphrase will be for every X, and then for every Y, X likes Y. Here, because the scopes overlap, we cannot use X twice. We have to use a different variable, right? In this case, we're using Y, to make it clear that we're talking about two things and to make it clear which each of those quantifiers range over, which specific thing. So our symbolization here is going to be for every X and for every Y, X likes Y, right? LXY. Next, we have every animal likes at least one animal. So now we've got a universal quantifier, right, for every, and then the existential quantifier for at least one. So now we need to say for every X, there is some such Y that X likes Y, right? Here is X is the every, Y is the existential, and then we need to make sure we put them in the right order so that it's every animal likes at least one animal. And we get this symbolization. For every X, there is some Y such that X likes Y. Now we have there is an animal that likes every animal. So there is just one animal that likes every other animal, including themselves. So here we're going to change the order. Our paraphrase is going to be, there is such an X that for any Y, X likes Y. There's at least one animal that for every other animal, X likes that animal. So we get there exists an X such that for all Y, LXY. Notice these changing in the order of the quantifiers does change the meaning of the sentence. Next, we have there is an animal that is liked by every animal. This is importantly different from the last one. Here we have the quantifiers in the same order, right? We have there is an X such that for any Y, but this time we have to make sure we change the order such that Y likes X, right? We need to make sure that there is an animal that is liked by every other animal. So we have there exists an X such that for all Y, LYX. Right? These two look very, very similar, but the change in the order of the variables attached to that predicate does change the meaning. 3 is there is an animal that likes every animal, and 4 is there is an animal that is liked by every animal. Now I'm going to briefly step away from the problems that we're working with here just to give you another set of examples to kind of impress how important the ordering of your quantifiers is and how important the ordering of the variables is. So this is going to be our one predicate, right? We have mxy, x is the mother of y. When we see this sentence, we have for every y, there exists an x such that x is the mother of y, right? For every y, there is an x such that x is the mother of y. When we put that in natural English, we get everyone has a mother, right? This one's true in at least some substantive sense, right? Everyone was given birth to by someone. So this order gives us a true sentence. If we flip the order of those quantifiers without changing the variables attached to them, we get there is some x such that for every y, x is the mother of y, right? And when we put that in natural English, we get someone is the mother of everyone, including themselves, right? This one is definitely false and definitely has a different meaning than the first one, just by changing the order of those quantifiers. Now let's look at this one. It looks like the first one, except we've changed the variables attached to each quantifier. Now we have, for every x, there is some y such that x is the mother of y, right? It sounds very similar, but the meaning here is different because now we're saying everyone is the mother of someone, right? For every x, there is some y such that x is the mother of y. Everyone is the mother of someone. So changing those quantifiers, or changing the variables attached to the quantifiers, or instead we could have just kept this order and changed it to nyx. But either way, changing those variables and changing the order of things makes a really big difference. So now let's flop the order of the quantifiers from that last example. Now we have there is some y such that for all x, x is the mother of y. So there's some unique y such that everything is the mother of it, right? There's some y such that everything else is the mother of that y. So put in natural English the best way I can, it's saying someone is the child of everyone, including themselves, right? Everyone, including themselves, is the mother of this unique someone, which is quite odd, right? That's also quite false. So we're going to get back to the examples that we started with about the animals, but I did want to go through these just to make it really clear how important the ordering of quantifiers is and how important making sure you have the right quantifiers attached, the right variables attached to the quantifiers and the variables in the right order. So now we're looking at a little bit more complicated example, right? This isn't just every animal likes every animal. Now we're specifying that every gorilla likes every rhinoceros. And to start out, we can think of this as the type of claim where we say all A's are B's, right? All humans are mortal, that type of thing. We're going to use a universal quantifier and then a material conditional. And we can start thinking about it like this. So this is our half-done truth functional paraphrase. For every x, if x is a gorilla, then x likes every rhinoceros. Now we need to do some more work to get x likes every rhinoceros into a paraphrase we can actually symbolize, but it's a good start. So we know our symbolization is going to look like this, and now we just need to figure out the consequent. So when we think x likes every rhinoceros, we can think of that as for every y, if y is a rhinoceros, then x likes y, right? Because we're making another universal claim about something that's true of every rhinoceros. So we're going to do it the same way with a universal quantifier and then a material conditional. So now our completed paraphrase, we have for every x, if x is a gorilla, then for every y, if y is a rhinoceros, then x likes y. So for every gorilla, they like everything that is a rhinoceros, right? And here we have these parentheses in, right? I have these brackets instead of the circular parentheses to indicate everything that's in the scope of the first quantifier, the one that governs x. It needs to come all the way here to the end because we have an occurrence of x right here in the consequent. And then the quantifier for y, for every y, is just going to have the rest of that consequent in its scope. So our symbolization looks like this, right? For every x, if x is a gorilla, then for every y such that y is a rhinoceros, x likes y. Every gorilla likes every rhinoceros. Now we have every gorilla likes at least one rhinoceros. The first half of this is going to be exactly the same, right? We're going to say for every x, if x is a gorilla, then something that says x likes at least one rhinoceros, that they like at least one rhinoceros. So we're going to do that with an existential quantifier, and we're going to do it this way. So the consequent here is there is a y such that y is a rhinoceros and x likes y. Notice here we're using a conjunction, not a material conditional. This is very, very, very common. You're usually going to see existentials paired with things like conjunctions and universals paired with material conditionals. Sometimes you might have a very strong claim, right? Such that everything in the universe is a fuzzy dog or something. And then you might have a conjunction as the main connective inside a universal, but you're almost never going to see an existential quantifier paired with a conditional. So definitely kind of keep that rule of thumb in mind. When you see a existential, it's usually going to be something like a conjunction. And when you see a universal, it's usually going to be something like a material conditional. But anyway, here's that completed symbolization, right? We have for everything, if it is a gorilla, then there is something that is a rhinoceros, and X, the gorilla, likes them. Now we have every gorilla likes at least one rhinoceros and does not like at least one jaguar. So the first part of this is really easy, right? Every gorilla likes at least one rhinoceros is something we just did. Like that was just our last problem. So it looks like this, right? For every X, if X is a gorilla, then there is a Y such that Y is a rhinoceros and X likes Y. Now we need to figure out how to add in that and does not like at least one jaguar. You might think we leave this alone and add a conjunction somewhere out here on the outside of these brackets, right? But notice that the subject of does not like at least one jaguar is still every gorilla. So what we add in here to say, and every gorilla does not like at least one jaguar, is going to be part of that consequent. So we need to add, there is something that is a jaguar that X does not like to that consequent. So we add another set of parentheses. I have that parenthesis inside it in yellow so that we know we're adding that to our consequent. This whole part is the consequent. Here we have to use a z, right? We need a new variable. And there is a z such that z is a jaguar and it is not the case that X likes z. So for every gorilla, we know that if something is a gorilla, then there is something that's a rhinoceros that X likes, and there is something else that is a jaguar that X does not like. And we get this completed symbolization. Now this problem is a lot more complicated than anything I'm going to give you on the exam, so do not panic that it seems like a lot. It is a lot. But again, we have for every X, if X is a gorilla, then there is some Y such that Y is a rhinoceros and the gorilla likes Y. And there is some Z such that Z is a jaguar and X, right, referring back to our gorilla, does not like Z. Now we have some tigers like all the jaguars, but no tiger likes any grizzly bear. So we're going to change that but to an and, right? And that's our main connective here because we have our quantified statement here, right? Some tigers like all the jaguars. And then the separate quantified statement, no tiger likes any grizzly bear. Our first conjunction is some tigers like all the jaguars. Now we have some, so we know that this is going to be existentially quantified. And because we know that, we can think about this as a conjunction and get the paraphrase. There is some X such that X is a tiger, and for every Y, if Y is a jaguar, then X likes Y, right? That second conjunct in there is just that likes all the jaguars. So we need to say, if something's a jaguar, then it's liked by this tiger, right? The tiger X that there is at least one of. and we get this symbolization. There exists an X such that X is a tiger, and for all Y, if Y is a jaguar, then X likes Y. So there is some tiger that likes everything that is a jaguar. That if something is a jaguar, X, our tiger, likes it. Our second conjunct is no tiger likes any grizzly bears. And again, these no statements, there's a couple of ways to do it, but I'm going to do it this way, treating it as a universally quantified material conditional. So we need to say, for every X, if X is a tiger, then it's not the case that X likes any grizzly bear. And we break that down into another material conditional. So our full paraphrase is, for every X, if X is a tiger, then for every Y, if Y is a grizzly bear, then it is not the case that X likes Y. And we get this symbolization. For all X, if X is a tiger, then for every Y, if Y is a grizzly bear, then it is not the case that X likes it. So this is, every tiger does not like every grizzly bear, or no tigers like any grizzly bears. And then we put it all together with that conjunction, right? We get these two statements. There is some tiger such that for anything that is a jaguar, the tiger likes it. And for everything, if it's a tiger, then it doesn't like anything that's a grizzly bear. So those were some examples, and they were long examples and fairly difficult ones. The textbook goes through a process of doing those and a bunch of other examples. I do recommend you look at those problems. They start on page 286, as I mentioned before, and go through the next several pages. It works through these problems. Here I have some recommended practice for you. These problems are easier. They're not the same type of thing. This last one, 4G, is a little bit intimidating to get started with, but as usual, I'm going to work through all of these problems in the next practice video. So that was just the start of multiple quantification, using some pretty intense multiple quantification symbolization problems, but hopefully it gave you a good feel for this, and the easier problems we do in class and the easier problems you'll ultimately have on your exam should be no sweat.